Welcome, grade 10s. Today we're going to be looking at trig ratios on a Cartesian plane. So you must remember your acronyms SOHCAHTOA or ROCHASHOTAO, whichever acronym you use for the trig ratios, because we will be introducing first some reciprocals of the trig ratios. So let's look at the reciprocals of the trig ratios. So these three reciprocals, they are not inverses, but we call them reciprocals of the trig ratios. So we've got sine theta, which remember it's opposite of hypotenuse. So the reciprocal is cosecant theta, which will be hypotenuse over opposite. And then cosine theta is equals to adjacent over hypotenuse. So the reciprocal is secant theta is equals to hypotenuse over adjacent. And then we've got tangent theta, which will be equals to opposite over adjacent. And the reciprocal is cotangent theta, which will be equals to adjacent all over hypotenuse. And then sine, we abbreviate it sin, cosecant, cosec, cosine, cos, secant, sec, tangent, tan, and cotangent, cot. So those are the abbreviation when we write them in short. Now, today we said we are going to look at the Cartesian plane. So the Cartesian plane is remember, we've got the x-axis is a plane which is divided by the x-axis and the y-axis, and it is divided into 4 parts, and we call those 4 parts quadrants, right? So given the circle, right, with the center at origin, and this one has got a radius, right, we call the radius r. We are going to be dealing a lot with the radius r. So we'll be moving the angles, we'll be moving or measuring the angles in anti-clockwise direction. So we said that the Cartesian plane is divided into the first quadrant, the second quadrant, the third quadrant, and the fourth quadrant. So we've got 4 quadrants of the Cartesian plane. And what is special about these quadrants, according to when we are doing trig, is that the first quadrant we've got acute angles, second quadrant obtuse angles, third quadrant reflex angles between 180 and 270 degrees, and fourth quadrant reflex angles between 270 and 360 degrees. Okay, 360 degrees. So this is supposed to be 360 degrees. Right. And the angles, like I said, they are measured in anti-clockwise direction. So you see in the first quadrant, we said we've got acute angles, and in this quadrant, x and y are both positive. In the second quadrant, so we say in the first quadrant, x and y are positive. So x and y, the coordinates of the points in the first quadrant, are both positive. So x and y are positive. In the second quadrant, we know that the x coordinate is positive and the y coordinate is negative. And in the third quadrant, the both coordinates actually are negative. And in the fourth quadrant, the y coordinate is negative. Okay, so we'll be drawing right angles, triangles there. So you will see that our angle theta in the first quadrant, the opposite side will be the y coordinate and the adjacent side will be the x coordinate. In the second quadrant, again, the adjacent side is the x coordinate and the opposite side is the y coordinate, right? And you can see in all the quadrants, the adjacent side is always the x coordinate and the opposite side is always the y coordinate. So keep in mind of that. Now let's look at the first quadrant. So trig ratios in the first quadrant, right? So we've got our Cartesian plane. So we're going to draw the radius of the circle, r, it is in the coordinates x and y. So there is our radius, which is the line from the origin to the point, right? And then we draw our right angled triangle. Remember, trig ratios, we're dealing with right angled triangles. And in the first quadrant, we've got acute angles, and our angle theta, meaning that it will be between 0 degrees and 90 degrees. So sine theta is equals to y all over r. Cos theta is going to be x all over r. Remember, you will be using your trig ratios. Sine is opposite over adjacent, and then cos adjacent, sine is equals to opposite over hypotenuse, cos adjacent over hypotenuse, tan opposite over adjacent, and then we have got the reciprocals there. And then you will see that in the first quadrant, all the trig ratios will give you positive values. All the trig ratios are positive values. Right. So you see that also the reciprocals are also positive. This is because all of them are acute values, and the coordinates, all of them are positive. Right. Moving on to the second quadrant. So trig ratios in the second quadrant, right, drawing the Cartesian plane, the coordinates, remember the x coordinate in the second quadrant is negative and the y coordinate is positive. And in here we've got obtuse angles, remember, between 90 degrees and 180 degrees, right? And the angle is represented by 180 minus theta. So the angle is 180 minus theta, which is an obtuse angle in the second quadrant. So trig ratios, sine of 180 minus theta will be positive, which is, and then, so we're using that triangle. And then cos 180 minus theta is, since x coordinate is negative, cos 180 minus theta is negative. Same with tan theta is negative. So the same with the reciprocals, cosec of the angle will be negative, will be positive, sec of the angle will be negative, and cot of the angle will be negative. So in the second quadrant, it's only sine which is positive. The other ratios will be negative. Very important. So in the second quadrant, only sine is positive. The rest are negative, because you can see with the trig ratios, when you use your trig ratios, you see the x coordinate is negative, and the sine ratio does not contain the x coordinate or the x value. Right, moving on. In the third quadrant, right, remember here we are talking about reflex angles. So again, in the third quadrant, the x and y coordinates, both of them are negative, right? So the only positive is the radius r, right? So the angle again, it's 180 plus theta. Now in the third quadrant, the angle will be 180 plus theta. So trig ratios, right? The trig ratios here will be the sine ratio, you see it's negative. The cos ratio is negative, and the tan ratio is positive. Same with the reciprocals. The reciprocal of sine, which is cosec, is negative. The reciprocal of cos, which is sec, is also negative. And the reciprocal of tan, which is cot, is positive. So in the third quadrant, only tan is positive and the rest will be negative. So tan and its reciprocal are positive in the third quadrant. You can see that the third quadrant is the straight line 180 plus any angle that comes after that. That's why we say 180 plus theta. Moving on. Now in the fourth quadrant. So trig ratios in the fourth quadrant. So here the fourth quadrant, you must know that the x value is positive, the x coordinate is positive, and the y coordinate is negative. And in this quadrant, the angle is 360 minus theta. 360 minus theta. It's almost a revolution, complete revolution there. So again, it's a reflex angle. So the trig ratios, you see that this trig ratio, the sine of 360 minus theta is negative, and the sine of 360 minus theta, cos of 360 minus theta, will be positive, and the tan of 360 minus theta will be negative. Same with the reciprocals. The reciprocal of sine, which is cosec, is negative, and the reciprocal of cos sec theta is positive, and the reciprocal of tan theta, which is cot theta, is negative. So in the fourth quadrant, it's only cos which is positive. So in the fourth quadrant, only the cosine and its reciprocal is positive. Okay, so now we need to look at how we can use this information. I've got examples which I have done for you. I've got 3 examples, very useful. Right, now let's summarize all this. We can summarize all this by putting everything in one Cartesian plane. All the information that we have done, we can summarize it, put it all in one same Cartesian plane. If we've got, remember, the Cartesian plane is divided into first quadrant, second quadrant, third quadrant, and fourth quadrant. Right, in the first quadrant, this is an angle which is an acute angle between 0 and 90 degrees. In the second quadrant, obtuse between 90 and 180. In the third quadrant, reflex between 180 and 270. And in the fourth, reflex again between 270 and 360 degrees. And in the first quadrant, all the trig ratios are acute angles, and they are positive because all the coordinates of the points in there are positive. And in the second quadrant, our angle, which is 180 minus theta, sine is the only trig ratio that is positive. The rest are negative. And in the third quadrant, we've got the angle, which is 180 plus theta. And in this quadrant, only tan theta is positive. And in the fourth quadrant, right, in the fourth quadrant, you see that it's only cos which is positive. And remember, in the first, it's acute angles. In the second, obtuse angles. In the third, reflex angles between 180 and 270 degrees. And in the fourth quadrant, reflex angles between 270 and 360 degrees. Okay, right. So this is the summary of trig ratios in a Cartesian plane. So now we want to do some examples. I've got very good informative examples which I have done for you guys, which I believe are going to be very helpful. Let's look at the first example. The first example, number 1, if 12 cos theta is equals to 5 and theta is an element between 270 degrees and 360, with the aid of a diagram, solve this. With the aid of the diagram, calculate cos theta minus sin theta. So the moment you are told that theta is between 270 and 360 degrees, you know this is the fourth quadrant. So in your diagram, you put your coordinate in the fourth quadrant, which is going to there. We put our radius in the fourth quadrant, and then we see cos theta is equals to 5 all over 12. So cos theta is opposite over hypotenuse. So we draw our right angled triangle and we put our hypotenuse 12, we put our adjacent 5, which is the x coordinate, and y. Right. So here we can see that now after using Pythagoras, we can see now we have the coordinates. The coordinates will be 5 and square root of 119. So basically this will be a negative value. This will be a negative square root of, so basically this is a negative square root of 119, because remember in the fourth quadrant x is positive and y is negative. So x is positive and y is negative. So this will be a negative value of 1 square root of 119. So when you find the square root of a number, remember, you will get a plus or a minus. So here you have to come and conclude that it is a negative 119. Right. And then we continue with our calculation, sine theta. So sine theta is going to be opposite over adjacent. Remember, this is a negative amount, value. So it's going to be negative square root of 119 all over 12. Of which now, after finding sine, cos we have it already, we can now calculate. This is, remember, negative, so it's a negative. We multiply with a negative there, so our answer is going to be a negative. Right, our answer is going to be, remember the question says without the use of a calculator. So if we don't use a calculator, this will be 5 all over 12 minus square root of 119 all over 12, which give us the answer 5 minus square root of 119 all over 12, because they have a common denominator. So that will be the answer, 5 minus square root of 119. I hope that was helpful. So the idea, the clue there was, in which quadrant do you draw your right angled triangle? Okay, moving on. Example number 2. Example number 2, you say given, right? Given that point A, which is x is negative and y is positive. So which means this is the second quadrant. You can just tell already you are given a point, you must know where you will locate that particular point. So here x is negative and y is positive, second quadrant. Given that, they say determine sine theta, cot theta, sine theta multiplied by cos theta without the use of a calculator and with the aid of a diagram, which means we have to put all this information and draw a diagram, a Cartesian plane. So drawing the Cartesian plane, remember it's in the second quadrant. We put our coordinate, we draw our right angle triangle, and we put the dimensions with our radius there. We can now use Pythagoras to calculate the radius, and our r there with radius is going to be equals to 5. Now we know sine theta will be equals to, we use the triangle there, the right angle triangle, opposite over hypotenuse is 4 all over 5. And then cot theta, which is the reciprocal of tan, it's adjacent over opposite, which is negative 3 all over 4. And then C, cos theta multiplied by sine theta. We know sine theta, but we don't know cos theta. We have to determine what is cos theta. Cos theta is adjacent over hypotenuse, which is cos theta will be equals to negative 3 all over 5. Now sine theta multiplied by cos theta, we have the values 4 all over 5 multiplied by negative 5, negative 1 all, negative 3 all over 5. We multiply that, we get the answer negative 12 all over 25. So you need to know in which quadrant your diagram or a right angle or your coordinate is going to be located. So you use that information using all the necessary information that we have learned in this lesson earlier. Now moving on to example number 3. Example number 3, we have got point O is the origin, right? And C, which is x and negative 12. So in this particular question, and then we are given OC, the line OC from the origin to point C, which is the radius, is 18 units. They want us to determine x, they want us to determine sec theta, they want us to determine cosec theta, and D, they want us to determine sine theta plus 2 tan theta. We are going to use a diagram and not a calculator. So you can see the clue here. We are given that there's a point x and negative 12. So we don't know the value of x, but we know the value of y. So we can narrow down on to say which quadrant or quadrants are we going to be working with here. So since our y is negative and we don't know the value of x, which means our point can either be in the third quadrant or fourth quadrant. Can you see that? So our point is going to be, so we have to put them both because we are going to have two answers for all these questions which they have asked us to do. So we've got 2 points. It's either going to be in the third quadrant or in the fourth quadrant because we don't know the value of x, but we are given the radius and a y coordinate. So we can still use Pythagoras to find the value of x. So using Pythagoras, we can say our x will be equals to square root. So remember, the answer out of a square root sign we are going to have two values, a negative and a positive. So the negative is the one for the third quadrant and the positive is for the fourth quadrant. So now they want us to find the value of x. Out of x, we have got two values, plus or minus 6 root of 13. Now secant theta is going to be hypotenuse over adjacent. So we've got two answers. Option 1, sec theta will be 18 all over positive 6 root of 13, which will be 3 root of over the root of 13. And then option 2 is where we use the x, negative x value, which will be negative 3 all over root of 13. Right. Moving on. C, cosec theta. So cosec theta, you will see that with cosec theta, it's going to give us the same value, because in both cases we've got a negative y value and a positive radius, so the value remains the same, negative 3 all over 2. And then for sine theta plus 2 tan theta, we are going to have two values, right, in this case, because in both cases we've got different values of sine and cos of 10. So in the third quadrant, you see that our sine is negative and tan is positive. So it gives us a value which is going to be a positive value, right? So there we go. You can see that the values which we are going to get, the first one is going to be 6 all over root of 13, and the third one is going to be negative 2 all over root of 13. So those are the two different values, because remember we've got two possible values of x. Okay, I hope that was helpful. You need to now try some questions to practice.